We just have a quick video to play for you first.
GDevCon 2025? Come on in.
At Resonate Systems, we're engineers specialising in test and evaluation system integration. We help clients collect the right data in the right way, whether that's in the lab, out in the field, or somewhere in between. Our systems support defence, research, and industrial applications with a focus on reliability, responsiveness, and practical outcomes. We've delivered systems for everything from vehicle testing to long-term structural monitoring, often in environments where flexibility and durability really matter. Our work ranges from rapid test deployments to long-term monitoring systems, combining hardware integration with custom data workflows. No two projects are ever the same. We adapt our approach to meet each client's technical and operational needs. Here are a few examples of our work. In this project, we automated a near-infrared soil analysis workflow developed by research partners. We integrated robotics, data handling, and analysis routines to replace manual steps, increasing throughput and consistency. We're also capable of delivering condition monitoring systems for road tunnel ventilation, combining vibration, electrical, and structural data to assess fan health in real time. In one of our more complex projects, we developed a dual-site data acquisition system to qualify radar antenna performance. Each system captured synchronized multi-sensor data across millions of rotations, helping the end client characterize radar behavior in real-world conditions. We also help customers specify vibration test systems used to qualify a wide variety of products. Our team completed the commissioning of a high-force twin electrodynamic shaker system capable of generating up to 360 kilonewtons of dynamic force. For a small team, we can do quite a lot. But don't just take my word for it. Here's Maddie and Stephen, two of our gun developers, to give you a little more insight into what we do here at Resonate Systems.
Cool, there we are. Thanks Maurizio and Peter back at the office for putting that video together. As was introduced, I'm Stephen from Resonate Systems and Maddie here. So I think that was a sort of good intro to what we do. I think we've only got a short slot here today, so I thought instead of turning it into an ad, we might just run through some recent projects that we've done, and there might not be a huge amount of time for discussion in this block, but if there's anything that comes up and you've got questions, feel free to either find myself or Maddie or Mike around the place, and we can definitely have a chat afterwards. I guess I'll just get started. So this project here was with a company called Milford. It was a three-axis control system, compact Rio, Bosch Rexroth controllers, electromechanical actuators. It was sort of network streams, communication. It used NI, soft motion, rest in peace. A nice little project there, sort of pushing the limits of a real-time control system. There wasn't a huge amount of FPGA in this one, but it was pretty impressive with what we were able to achieve just with the compact Rio with a real-time control loop. This is just a few examples of a suite of applications that we've done for MicroX. So they're a company in Adelaide who actually make their own X-ray tubes, among other things. But it's pretty cool to see that happening in Australia. But we've worked with them on a range of sort of production test applications, which are based on quite a simple hardware set, lots of USB DACs, but some neat electronics to sort of extend their functionality. We've had great success sort of utilizing the good old JKI state machine on these ones. And yeah, we've developed sort of a wide suite of applications for production testing, conditioning of the X-ray tubes, and then lots of R&D work. So that's a mix of automated testing, operator interfaces, and then some more engineering style applications. Another one is it's called a flare test system. It's for conducting field trials and measuring signals of certain events. This was a nice application to work with. I think one of the highlight features of this one was saving entire sessions to TDMS files. So we were able to run field trials, restore previous sessions and continue on or review them at a later date. But one of the neat things about saving our sessions to TDMS file was it opened the option for viewing data outside of LabVIEW. So people were able to use Python or Diadem, even Excel to sort of look and view the same data that we were seeing in the LabVIEW application. So that was a nice little feature of this one. This one was a bit of a software and hardware project. So it was a series of wind monitoring station, well, not just wind, but that was the primary parameter being monitored, but it consisted of a base station and multiple substations, sort of spread out. I think the range was up to kilometers using some RF modules. But yeah, that was a nice example of handling sort of dynamic modules and being able to support a varying number of substations. And it was also a good showcase of, I guess, some of our mechanical side of things. I guess, we do a lot of test stand as well, which obviously I think a lot of people here are more on the test stand side as well. This is one we did recently for a customer making RF modules and for their production test after they've gone through and been finalized, just those final tests there. I just wanted to post a screenshot here just to showcase sort of how easy it is to get a test stand UI up and running in LabVIEW. I think that was something we sort of come across. There's not a huge amount of documentation online for getting up and running with a test stand UI. But if anyone's thinking about it and you don't want to go to a fully fledged web UI or a completely custom thing, there is included examples which can be extended very easily in a matter of hours, really, to sort of hide a lot of that test stand user interface and settings and whatnot, so you can sort of restrict it down and get a nice operator level interface up and running within hours rather than days or weeks. But yeah, that's sort of just a little test stand example. I'll just pass across to Maddie now, who will run through a few more.
Right, so along with completely custom applications, we've also had a bit of experience of inheriting code, perhaps the VI. So this system was done with Wabtec. So they have this wayside system that sits on train tracks, and among other things, it has an FPGA system that triggers camera shutters to open and capture pictures of train wheels to monitor their status. So on the left there is that inherited code, just one big FPGA VI that you had to scroll for miles in each direction. And then on the bottom right there is the current state of the FPGA. So we've just had to sort of refactor, clean up that FPGA code while developing unit tests for different parts of that code. And then the most recent project that we've been working on is the skill tester, which we have here with us today, which we've called Resonate with Resonate Systems. So we have developed it using DQMH with an API to communicate with a web server that keeps track of everyone's scores. So the whole concept behind it is that you generate a consistent oscillation in a limited amount of time to get a high score. You can check your live ranking at any time by coming by our booth, and the top scores will get some cool prizes. So yeah, just like to thank everyone for the opportunity to present and to sponsor GDevCon, and thank you for listening.